Okay, so hi everyone. This video is going to talk about dilutions, which is the process of taking a concentrated liquid and adding more of your solvent to it in order to make it less concentrated. So sometimes we do not have a solid compound to work with. It's not like we're making salt water by dissolving salt. In those cases, we need to dilute a concentrated stock solution in order to get our desired solution. So we can perform calculations for dilutions involving the following equation. M1 times V1 equals M2 times V2. And these labels actually do make a lot of sense. So M1 is the molarity of the first solution, and V1 is the volume of that solution. M2 is the molarity of our second solution, and V2 is the volume of the second solution. So the one thing I want to point out to note, solution 1 is generally the stock solution and is more the concentrated, but it doesn't really matter which one you make your 1 and your 2, you get the exact same answer. And then also the volume may be in any type of unit as long as it's the same unit for both sides of the equation. So this is very different from concentration, where we always were going to units of liters for our volume. For dilutions, we can use milliliters, we can use gallons, we can use ounces, we can use drops. As long as it's the same on both sides of our equation, we are good to go. Now, one really important thing is with diluting acids, we need to be careful with how we mix the acid and the water. If you do it the other way around, you can go ahead and have acid splash up in your face. You also get a lot of heat released really, really quickly, which can be dangerous. So this is the safe way to dilute acids, is to add the acid to the water like you otter. Okay, so a little mnemonic to help you out there. Add the acid to the water like you otter, because if you do it the other way, you're gonna get acid splashing up on your face and you're gonna need a lot of heat in a small container. Okay, so let's go ahead and work through 2 different examples. Okay, so let's work this first example. How much concentrated 18 molar sulfuric acid is needed to prepare 250 milliliters of a 6.0 molar solution? So a couple of things when it comes to dilution problems. The good news is I can use whatever volume I am working with. I don't have to change it to liters. I can use drops. I can use milliliters. I could use gallons. So that's some good news. It saves us some conversions with that. Now, the other thing I want to point out is you will always see 2 numbers paired together for dilution problems. So in this case, the 250 milliliters is paired with the 6.0 molar. So you see how they're all kind of together. So the 250 milliliters of, so that's going to be one set. So I can make that my 1s or my 2s. It really doesn't matter. I'm going to make it my 2s just because it comes at the end of my problem. But I could have it be the 1s as well. I'd get the same result. Oh, so I just made a really silly, simple mistake. Make sure you're paying attention to where you put things. So I need to flip-flop those around, okay? So my 6.0 molar, that's my molarity, and my volume is my 250 milliliters. Okay, so let me go ahead, cross that out. There we go. So moving on, the other number I'm given is my 18 molar. So that's going to go for my molarity, my M, which means my unknown is my V1. Okay, so if I set up my equation for dilutions, M1V1 is equal to M2V2. My unknown is my V1, so I want to get that by itself. So I'm going to divide both sides by M1. Okay, so this gives me the equation V1 is equal to M2 times V2 divided by M1. So all that we have to do is now plug in our values. So our molarity of our final solution is 6.0 molar. The volume of our final solution is 250 milliliters. Again, it's okay to be in milliliters for dilutions. It's not molarity where we have to be in liters. And then my initial molarity is 18 molar. And you'll notice 2 units will cancel out. In this case, it's my molarity, which leaves me with my milliliters for my unit of my final answer. So if I plug this into my calculator, 6 times 250 divided by 18. In my calculator, I get out an answer of 83.33 repeating. Okay, so again, I still need to think about sig figs. So I have 2 sig figs here, I have 2 here and 2 here. So that makes my life really easy. I just need to round to 2 sig figs. So 83.3 repeating is going to just be 83 milliliters. Okay, so let's try the next one. To what volume should 25 milliliters of a 15 molar nitric acid solution be diluted in order to prepare 2.0 molar solution? Okay, so I want to look for my 2 numbers that are paired together. In this case, it's 25 milliliters of a 15 molar solution. Okay, they're coming first, so I'm going to make those my 1s. They could be my 2s. You're going to get the same answer in the end. So my volume, if I put it in the right spot this time, is 25 milliliters, and my molarity is 15 molar. And then I am being asked to dilute it to a 2.0 molar solution. So this time my V2 is my unknown. So if I go ahead and set up my equation, M1V1 is equal to M2V2, I'm going to divide both sides to get my V2 by itself. I'm going to divide by my M2. Okay, so my equation becomes V2 is equal to M1 times V1 divided by my M2. So from here, I just need to go ahead and plug in my values. So V2 is equal to my initial my initial molarity, 15 molar, times my initial volume, which is my 25 milliliters. And then I need to divide by my final molarity, which is 2.0 molars. So I look for 2 units to cancel, so I'm left with only 1, which is milliliters, which makes sense for volume. Always want to make sure that your math is turning out in the way you expect. If you get really weird units, you're probably doing something wrong. So 15 times 25 divided by 2. So I would need to dilute this to 187.5 milliliters. But again, I need to think about sig figs. In this case, I also have 2 sig figs for every single number. So I'm going to chop off that 7, and that's going to get rounded up. Now remember, your numbers should mean about the same thing. 187 means about the same thing as 190. So don't round your answer to 19 milliliters. Okay, 19 milliliters is not right. Okay, because actually that would be making it more concentrated to make it more dilute, which doesn't make sense at all because we need our volume to increase for this problem. Okay, because we're diluting. So I hope that helps. If you have any questions, please go ahead and let me know. Have a great day, everyone.